Next up is Scott.
Hi, my name is Scott. I'm going to be a junior at Birchlough and Lennox, and I built 3 projects at Blue Stamp. 2 of them were starter projects and 1 main project. So one of the starter projects that I don't have here tonight is a mini piano, which uses my finger as a conductor, and then there's conductive material on the bottom, and it's separated by an insulator. So when your finger comes close to it, it creates a temporary capacitor, which outputs the electrical energy into the 18 mega microcontroller, which allows the whole piano to know which key was pressed, and therefore it submits that pitch. And then the starter project that I do have here today is the watch, and this watch uses a quartz crystal to allow the waves to oscillate inside, and it takes the frequency of that and uses that to determine what a second is, and then once it has once it determines how long a second is, it can then display the correct time on the monitor. And so my main project is the prosthetic hand, and I like to think of it as breaking it into 3 main steps. So the first step is assembling all of the pieces of the hand, like the fingers and the thumb housing, without any current real functionality. And then that brings you into the second step, because after you have all of the assembled parts, you want to add mechanical and electrical functionality. So the tendons, which are fishing wire, are put into the fingers, and therefore if you pull on the tendons, the finger will bend and unbend, so that's the mechanical functionality. And then the electrical is there are motors in here, 5 DC motors for every finger. And I built this trigger to go along with it, where there's 2 switches here. They're double pole, single throw switches, so that when you press down on one of the buttons, the switch closes in 2 different areas on the same switch. And this is significant because when you allow the current to flow out one way, you need to find a way to get it back to the battery to complete the cycle. And if it was only 1 switch, then you'd have to push down on 2 switches to complete that cycle. But instead, all you have to do is push down on 1 switch, and it allows the current to flow out one way, and then through the motors, which are set up in parallel, and back through the other way. And so that's the main functionality aspect of it, which brings me into my third step, which completes the functionality, which is the thumb. So the thumb is significant and is different than the rest of the fingers because it doesn't only have a DC motor in it, it also has a servo. And the difference between a servo and a DC motor is a servo is basically a DC motor, but it has a PCB in between it, so it indirectly goes to the motor. And this is significant because when the current flows to the PCB first, it then allows the Arduino to program it, and it tells the PCB exactly what position it wants the motor to go at. And so it allows me to vary the angle as opposed to just continuous movement. And so that completes the functionality aspect of it. And then, clearly, I wanted to make it aesthetically pleasing, so that's why it's in this shape and this format. And so this is the way it works. So the thumb rotates at various angles that it's set to, and then the fingers can close around it and open back up. And it has a pretty strong grip. So if I take this out, you can see it doesn't come out the hand. And so some of the problems I faced when working with this hand is the fingers were not moving. That's mainly all of the problems, but it always came about different ways. One of the most significant ways is that here I have all of the wires put onto a breadboard, but I didn't solder any wires down because I didn't want it to be a permanent connection, because ultimately I hope to have everything be Arduino based, and therefore a lot of the wires have loose connections, and it's kind of hard to pinpoint exactly where that loose connection is coming from, because as you can tell, there are many wires. And then the other main problem I had is that there are spools on the inside of this right here. On the inside of the hand, there are spools that keep the tendons in place and allow them to unravel and ravel again. And the problem with those are that they're very thin and the grooves aren't very deep, and so a lot of times the tendon will kind of jump out into place. And so one of the ways I hope to fix that is with this new and improved spool, which has deeper grooves, and it also has 2 holes, allowing me to put much more force on the motor shaft so that it has a better grip on the motor, and so that should increase its speed and its durability.
How do you think you can expand on that project?
Okay, so my future aspirations for this project would be, I wanted to ultimately be able to write efficiently, and the way I plan on doing that is by using electrodes to attach to the arm to pick up the electrical energy within your muscles and within your nervous system, and then transmitting that to through an EMG and into an Arduino, allowing me to convert that electrical energy to mechanical energy, where these fingers can then move and write precisely.
You said that the thumb is controlled by a servo. How are you controlling the servo?
So the servo is controlled by this Arduino, and that's why I couldn't use just a trigger for everything, because the Arduino allows it to be programmed using this USB port, and so if I upload my code into it, it'll tell the hand exactly what position I want it to go at and what speed I want it to go at, which is what differentiates it from the rest of the other motors.
How much do all the parts in the hand cost?
So this hand is very cheap in terms of its just mechanical structure, because it's 3D printed, and so it's just made out of plastic, and this whole roll of plastic could be as little as $10 to $20. So without the electrical component, the mechanical component itself is just $20. And so all I had to do was 3D print the models myself. So I made all of the individual pieces of this hand and then assembling it together.